Fine. Let us start the problems on Stokes theorem today. Just like the Gauss divergence theorem, in the electrostatics part, we have seen um, the problems where some field is given to you. You have verified the both LHS and RHS of Gauss divergence theorem, wherein LHS was surface integral, RHS was volume integral. So you have calculated both LHS and RHS, and you have showed that both are equal. Okay, the numerical value what you have got is equal. In the same line, even for Stokes theorem, okay, after curl we have seen what is Stokes theorem. Let me repeat it here. Here I have written the Stokes theorem definition here in the form of an equation. If you take the line integral of the magnetic field intensity over a closed path, okay, it is equivalent to the surface integral of the same magnetic field, its curl calculation, okay, over the surface. Let us solve the problems based on this now. First thing, question is evaluate both sides of Stokes theorem for the field. So value of H is given to you. You can see AX and AY are involved. So it is rectangular coordinate system. And there is a rectangular loop path is given. And that rectangular loop positioning is given here. With this X and Y ranges, you have to position this rectangular loop. You can see it is Z is equals to 0. So it is again on the floor. If you take this as X, this as Y, this as Z, it is somewhere here. There is no Z coordinate. Okay. So let the direction, positive direction of ds be AZ. Okay. What is this given? Let positive direction of ds. Suppose you have a surface, okay, any random surface. What will be the surface vector? Always it will be perpendicular to this. If I consider a surface like this, its a surface, the vector is in this direction, always perpendicular. So that direction is given. Is it is very obvious. अगर आप यहाँ पर floor पे surface draw कर रहे हो, तो surface vector का direction along AZ ही होगा. It can be positive or negative. So here they have given the positive value. Okay, assume it to be plus AZ, positive AZ. Now let us start with this LHS. How to calculate LHS? For that, where to locate the rectangular path is important. So let us do that. And here, just for your reference, I have written what is DL in rectangular coordinate system. We have already used this. In today's class also we have seen, we have taken a DL. 4 integrals we have used. Remember, we have for a loop, we have calculated 4 integrals. In some integrals we have taken dx, in some integrals we have taken dy. Okay, depending upon which coordinate is varying. Now, in order to locate this, I won't show you directly. I will draw it here. Then you will understand. This is your coordinate system. X, Y, and Z. I have to now mark the regions. So what I will do first, I will first mark out the X direction. So what is the X? It is a 2 and 5 plus 2. 2, 3, 4, and 5. Somewhere here it will come. So what I will do, hope it is visible to all of you. Shall I take the different color? This line indicates X equals to 5 and a 2. 1, 2, somewhere here. This line indicates X equals to 2. Okay, I have marked 2 lines. Now, talking about Y, minus 1 and plus 1. Let me take a different color. Minus 1. So Y, this is your plus Y and this is your minus Y. So if I take the Y along other direction first, minus 1. Let me mark minus 1. Somewhere here it will come minus 1. So I'm drawing a line from this. This indicates y equals to -1 and +1. Y equals to +1. This is your 0 point. +1 is somewhere here. Okay. So this is y equals to +1. So I have marked the points. Okay. This will make your work easier. अगर आप ऐसे lines draw करोगे, जहां पर भी common intersection area होगा, that will be your identified loop. So you can identify this is the loop. This is 1 point, this is 2nd point, 3rd point, and 4th point. Or else whatever method you follow in the class, you do that. That is much easier for you. Locate this point 2 and 5, -1 and 1, and draw the loop. I have shown you the possible easiest way to draw this loop. The same thing I have drawn. You can see what is the point here. It is x direction you have traveled to, y direction -1. Now, to get this point, you have traveled x direction 5, y direction -1. Okay, y is not changing, only x coordinate is changing. Now, talking about this point, you have traveled 2 units in x direction plus 1 unit in y direction, 2 and 1. Now, the 4th point, you have traveled 5 units in x direction, 1 unit in y direction. So it is 5, 1. Again, y coordinate is same, only x is changed. Hope it is clear to you how to draw the loop. Now, once you have drawn the loop, for this, according to the Stokes theorem, if I find line integrals for each of these lines altogether, okay, that is the line integral of HDL is calculated 4 times for 4 different lines. If I add them, that will give you LHS. That LHS value you will get some value, that is what? In amperes. Ampere's law says this is equals to I. So whatever answer you get is in amperes, that is one value. Then taking the RHS, H is given to you, get the del cross H, curl, then you take the dot product over the surface. If you find that ampere value, you will get some value. Both values you should get same. That is the verification. So for this loop, you can see I have marked for my reference A, B, C, and D. So starting with LHS, the total line integral I have divided among 4 different lines. This is our equation 1. I have to calculate these line integrals individually now. Let us take the first integration, line integral of between A and B, the first line. First line, you can see it is AB. Okay, this is the line which I am considering. Which coordinate is changing here? Observe, -1 is the same, but only 2 and 5 is changing. X coordinate is changing. So your integration is over X. And the H is given to you. Okay, it is HDL, right? H is given to you. Take it as it is. Dot. Which coordinate is changing? X. So hence DL will become DX. That's it. DX in AX direction. I have written here DL. Out of this, only this you have to consider. Further, take the dot product. When I take the dot product of first term with this, AX dot AX is 1. Okay, 6XY will remain with DX. But when I take the second term dot product with this term, 3y square AY dot AX will become 0, because angle between AY and AX is 90 degrees, cos 90 will be 0, dot product. So only first term will remain. So that is integration is from 2 to 5, 6x by dx. Integration is with respect to x. So y and 6 are constants. I have taken that outside. Integration of x is x square by 2. And applying the limits 2 to 5, 5 square that is 25 by 2 minus 2 square, 4 by 2. I have got 63y. But what is y for first line? Check the value of y. For the first line, it is constant. It is not changing. Only x is changing from 2 to 5. Y is minus 1 only for both points. So I am taking y equals to minus 1. Taking y equals to minus 1, the first line integral will be minus 63. 63 into minus 1. I have got some value. I have taken this as 2. Because first equation is already this sum, I have taken that equation as 2. First integration calculation is over. Now, in the similar line, let us go for second line. Integration of BC. Where is BC? Horizontal axis, horizontal line. I am now talking about this. Observe here in this, which all coordinates are changing, which coordinate is constant. Can you tell me, looking at the figure, looking at these 2 points, 5 and minus 1, 5 and 1, which coordinate is variable? Anyone would like to answer? Which coordinate is changing? 5 minus 1 and 5 1.
Y.
1. Y. Yes. Y is changing. Minus 1 and 1. But आप देख सकते हो x value 5 5. It is the same. So change is now with respect to y. So आप integration जब लोगे, this will be, sorry, I have not mentioned, it is y equals to minus 1 to plus 1. H. H is there in the formula. H, it is given to you. Dot. Now dl. Since the y is the variable, I am taking dy ay. Okay. This time, when you go for dot product, first term dot product with this, ax dot ay will become 0 now because 90 degrees angle. And taking this minus 3y square, ay dot ay is 1. So it is minus 3y square dy. There is no other term. 3 is constant. Minus 3 I have taken it as it is. Y square. Y square's integration is y cube by 3. And apply the limits. I have got, after substitution of the limits, as minus 2. Minus 2 is the answer. I have taken this as equation number 3. 2 is over, 3 is over. We have calculated 2 line integrals. Now, talking about the third, CD. Check this. CD. This too. See, the coordinates location is very important, because if that is wrong, if that goes wrong, complete problem will be wrong. So be careful to locate the points correctly. Okay. Now for CD, can you see which one is varying? 5 and 2, but y coordinate is 1 1 only. So here again in CD, variable is x, no doubt, just like AB line. In AB line also you have the variable x only, y was constant. But check the values. Here the limit was from 2 to 5. Now the limit is 5 to 2. Directions are opposite. Okay. You should make sure that when you take this, it is not 2 to 5, it is 5 to 2. Direction is opposite. So H and DL. So DL is x is changing. So this limit is for x equals to, and dx is the variable length. So integration of this, when I take the dot product between first element and this, you will have the value. But dot product of ay dot ax is a 0. Second term I will not consider. So it is a 6xy dx. In this again, 6y is constant because integration is with respect to x. So 6y is as it is. Integration of x is x square by 2. After applying the limits 2 and 5, I have got minus 63y. Earlier we had got 63y. Now it is minus 63y. But what is y? For this line, check what is y. y is 1, which is constant. Earlier y was -1, but इस बार यहाँ पे इस line के लिए y is 1. So substitute that. Y is 1. Your integral value is -63. Give that equation number 4. So we have calculated 3 line integrals now. Now only last one, dA is remaining. Talking about this fourth line. Again, you can see x coordinate is same, 2, 2. But y coordinate is changing, 1 to -1. Okay, direction is like this. So 1 to -1. So if y is the variable for the fourth integral, y equals to 1 to -1. H is given to you, dot dy. Now taking the dot product between first element and this dy ay, it will be 0. Ax dot ay is 0, but second term will remain. That's why I have written -3y square dy, and ay dot ay is 1. -3 kept as it is, y cube by 3 integration. Applying the limits, I have got +2. So this is numbered as equation number 5. So I have calculated all 4 line integrals, substituting all these 2, 3, 4, 5 in equation 1. What is equation 1? This is our equation. LHS, you have to add all your answers. Then you will get LHS of the Stokes theorem. So I have added here, you can see first value -63, second value -2, third value -63, fourth value +2. So these two cancels. -63 and -63, we have got -126. I said integration of, line integral of HDL is Ampere's law. According to that, it is equals to current I. So I have written the unit amperes. Okay. Hope you understood the LHS part of the calculation, Stokes theorem. This resembles to the problems that we have been doing since the 2 previous classes. So it may not be much problem for you to understand this loop problem. Okay. Now coming to RHS of the Stokes theorem. So we should prove that RHS also you should get -126 amperes because it is verification. So what is RHS? You can see this is the RHS. You should have surface integral of del cross H. So आपको del cross H calculate करना है first, उसको integrate करना है over the surface. Okay. So del cross H, that is curl of H you have to calculate. For that, it is again rectangular coordinate system है. Simple होगा determinant form. See, this is the del cross H, Ax, Ay, Az, dou by dou x, dou by dou y, dou by dou z, Hx, Hy, Hz. So what is H given to you? Here it is, I can show you. Here itself I have written. This is the H given. Okay, it is given in the question. I have used the same H here. It has Ax and Ay coordinates only, no Az. Okay, and what is Ax coordinate? 6xy. Ay is -3y square. So I have substituted 6xy -3y square. So further, you have to calculate this determinant. I have done that. Be careful here while selecting which is constant and which is variable. Suppose when I take first with respect to Ax, this Ax into, you should multiply these two. So this anyhow will be 0 minus dou by dou z of -3y square. See, differentiation is with respect to z, but you have the variable here, the value is -3y square. So with respect to z, y is taken as constant. Hence, this will also become 0 further. Okay, it is 0 I have considered. And even for Ay also in the similar line, 6xy. With respect to z, again, this will be eliminated. So both Ax and Ay will not be there. Only Az term will remain. Okay, that you can calculate here. It is again with respect to x. This is with respect to y. Only one differentiation exists. That is with respect to y is 6x. That to minus 6x. That I have written minus 6x az. This is del cross h. But what is your RHS? This. In order to calculate this, surface integral hai. So I am taking two integrations. Del cross h. I have got this del cross h into, yes, what I have to consider this ds. Obviously, in order to, for the dot product to exist, you should consider az direction because it is given in the question.